Right. So now, to verify Mr. Thomas's idea. So we start off by analyzing the claim. The claim is 85% of the phones are healthy. So if I have to analyze a variable or analyze something, what am I measuring here? What am I testing? Let x be the number of x would be the number. So what I am testing here is x would be I'm going to start with the number of, so you can do either healthy or unhealthy. Because the claim is 85% of them are healthy phones, I'm going to say let x be the number of healthy phones. So whatever is the variable that you are analyzing or you're testing your claim with, this is called the test statistic. So the variable that you're using to test the claim or to analyze the claim or infer, we call that as the test statistic, and x is usually represented as the test statistic. So x here is the number of healthy phones, and we're going to measure the theory, or we're going to test the theory using the number of healthy phones. So the claim is 85% of them are healthy. So if I translate that to maths, 85% of them being healthy would mean the chance of getting a healthy phone is 85%. So in terms of probability, I can say probability of getting a healthy phone is 85%. So 85% is healthy, that is math. So in terms of, that is English. So I can say the math version of this would be the probability of getting a healthy phone is 0.85. Okay, this is Mr. Thomas's claim. Now somebody told you Mr. Thomas is a shady guy, so there is a counter claim. What will be the counter claim? So he claims 85% of them are healthy. So opposite of that would be? So there is something, so you can say what Mr. Thomas claims is not really true. Do you think you would say the number of healthy phones or the percentage of healthy, would it be, do you want the counter claim to be more than 85 or less than 85? Less than 85. Because you think Mr. Thomas is a crook, so what he claims is not true, which means the probability of healthy phones should be less than 85. That is your counter claim. Okay? So you can say the probability is less than 0.85. Why? Because you think he's a crook. You wouldn't take that to be more than 85. That doesn't make sense. If you say the probability of that is more than 85, then he must be a very nice businessman. He is saying 85, but the reality is he's giving you more healthy. No, Mr. Thomas wouldn't do that. So he claims 85% of them are healthy, but you feel doubtful. You are not trusting him. So you think, well, I don't think 85% of them are healthy. Less than 85 may be healthy. So that is your counterclaim. So the counterclaim is less than 85% are healthy. Okay. So first you have a claim, then you have a counterclaim, and you also have the test statistic. The claim that everyone makes, or the claim that you make at the beginning of a hypothesis testing, we call this as the null hypothesis. Okay, so claim is your normal English word. The math word is null hypothesis. Null hypothesis means this is your original claim. What do you claim, or what does Mr. Thomas claim originally? He says the probability of getting a healthy phone is 0.85. but you are making a counterclaim. You're not trusting Mr. Thomas. You're making a counterclaim, and the technical word is alternate hypothesis. Or this is the counterclaim that you are making. And the counterclaim here is not 85%. Well, it is less than 85. It's not, he is not as an honest person as we think him to be. It's only less than 85, which are really healthy. So you can say probability of getting a healthy phone is not 85, it is less than 85. So that's how we start hypothesis testing with. You have X as the number of X is your test statistic, which is the number of healthy phones. You have your null hypothesis, which is the original claim that P is 0.85. Then you have your counterclaim, which is P is less than 0.85. Now, the notation for the null hypothesis is, you don't have to write null hypothesis every time. You can say H0 with a colon, that is your null hypothesis. So H0 is your original claim. Your alternate hypothesis is given by H1, which is less than.